Leetcode 104, maximum depth of a binary tree. Given the root of a binary tree, we return its maximum depth. A binary tree's maximum depth is the number of nodes along the longest path from the root down to the farthest leaf node. So for this one, we would have 3. If we had this tree, which we kind of can't see, let's go to the console and visualize it. Okay, so we have 2 nodes, and then if we have an empty node, we would just return 0, and if we have a single element, we'll return 1. So what this question's asking is that no matter how large our tree is, we basically need to traverse it and figure out what the maximum depth is going to be. So there's basically, I kind of drew the tree out here. So if we have 3, 9, 20, 15, 3 for the root is basically the first level, 9 and 20 are considered the second level, 15 and 17 are considered the third level. If we had something like a 9, another 9, well, duplicates probably doesn't matter. There's duplicate values. But if we did, then the max level would technically be 4 in this case. And then if we got rid of these other 2 levels, then the max depth would be 2 if we just had a tree like this. So the depth first traversal is basically all we're going to do is recurse, kind of like a brute force recurse both sides of the tree, and at each recursive call, when we hit the end, we're basically going to add 1 to our element, to our drawing a blank. We're gonna add 1 to each level, more or less, and then we want to return the max of whatever level is the most. So implementing that, we would basically say if there's no root, then we're going to return 0. Otherwise, we're going to return the max of recursive call of root.left, and then root.right, and then we'll add 1. So it's kind of trying everything at the same time. Not really at the same time, but we're trying the left and trying the right, and then trying to figure out whatever the max of that's going to be, and then return it. So this is a recursive solution. Only 2 lines, so it's not that bad. The breadth first search, we're basically, instead of using the recursive call stack, we'll use a queue, and then we're basically going to keep track of our node and then the depth. We might want to create like a max variable to keep track of whatever our max depth is going to be, and then ultimately we're just going to return whatever that max is going to be. So we use a queue, traverse left and right doing the same thing, and then ultimately return that. So this trick will definitely help you out as far as a lot of the breadth first search questions. It's kind of, instead of just keeping track, instead of just pushing, there should be a subarray actually. So instead of just keeping track of our node and of a single node in the queue, it also makes sense to keep track of like your node and your depth, or this could be like a counter, or this could be like a couple of different other things depending on what the question's asking, but definitely helps. So we'll do queue, which will have our node, and then we'll have 1. This is going to be the root. I already messed up. We'll check if there is no root. We'll return 0, which is the edge case we have down here. For example, 3. If there's nothing, we'll return 0. And then let's also create our max. Just to be fancy, we'll do negative infinity. We probably could have done 0, and infinity's overkill, but I mean, who cares? We're having fun. So we'll say while the queue is not empty, we can grab our node and our depth, current depth, from the queue. And then we'll say if there's a left node, then we'll push a subarray of the node dot left and our current depth plus 1. And then if there's a right node, we'll push our right node and then increment the depth. And then ultimately, the main thing we care about is the max of either whatever previous max was or depth. So stepping through this, we'll always grab whatever the depth is going to be. We're going to start it off at 1 because like what we had here, the depth should always be 1 if our root isn't null or isn't empty. And then we will reassign our max variable to either the max or the depth. And then if there's a left node, we'll add the left and increment the depth by 1. So same thing, if we have 9, we go to the left. And then we would increment the depth, which basically means the level is 2. And then the same thing if we go to the right, we'll traverse to the right and then increment the depth by 1. Cool. So those are the two approaches, depth first search and breadth first search. It definitely helps to try to implement both for any tree questions you might run into. But that's it. Like, comment, and subscribe, and I'll see you in the next video.